What if I told you that addiction isn't really about willpower or about being a bad person? What if it's about brain chemistry, about a survival system that gets hijacked? Today, we're going to look at what's actually happening inside the brain and, more importantly, how it can heal.
Okay, let's just start with this. This number. For someone who's been in recovery from addiction for 5 years, their chance of relapse is less than 15%. You know what that is? That is the exact same risk the average person has of developing an addiction in the first place.
So, wait a minute. That begs a huge question, right? If addiction is this, powerful compulsive brain disease we're always hearing about, how can that be? How can someone's brain get back to, well, normal? That's the mystery we're going to unravel today.
To understand how the brain gets hijacked, we first have to understand what it's doing in the first place. Turns out, the very system addiction messes with is the one designed to keep us alive.
See, your brain has one main job: keep you going. And to do that, it's developed this brilliant little reward system. When you do something essential for survival, like eating or connecting with people, it gives you a little hit of pleasure. It's the brain's way of saying, yes, that was good. Do that again.
And this is the basic machinery that runs the whole show. You've got the VTA, think of it as the spotter. It sees something good. It then fires off a dopamine signal to the nucleus accumbens, which is kind of like the feeling center. And then the prefrontal cortex, the CEO of the brain, steps in and goes, okay, log that. That was important. Let's make sure we do that again. Yeah, it has a fancy name, the mesocortical limbic pathway, but honestly, just remember these three parts.
Now, when it comes to natural rewards, the signal is, well, it's polite. It's a healthy, manageable little bump. But addictive substances, they don't play by the rules. They don't just tap into the system, they blow the doors off. They create this massive, artificial flood of dopamine that the brain has just never seen before.
And right there, that's where it all begins. This elegant little survival circuit gets forcibly taken over. It gets hijacked. And here's something you really got to understand about dopamine. We all call it the pleasure chemical, but that's not quite right. It's really the motivation chemical. Its job is to scream, hey, pay attention, this is important. It's what drives the wanting, the craving, the urge to do it again. Just look at this to see the scale of the hijack. Eating some good food, you get maybe a 50% bump in dopamine. Sex, around 100%. Both feel great, right? But cocaine, 350%. And other drugs can be way, way higher. It's not even in the same league. Your brain just isn't built for that. It's like putting rocket fuel in a lawnmower. The whole system goes into overdrive, screaming, this is the most important thing for survival ever, even though it's a complete lie. So what happens when you send that overwhelming signal over and over and over again? Well, the brain does what it does best. It learns, it adapts, it literally starts to physically change, creating what we call a compulsion loop. So let's get into it. What does this repeated, unnatural flood of dopamine actually do to the physical hardware of the brain? It adapts, all right, but not in a good way. Through a process called neuroplasticity, the brain literally starts to rewire itself. It begins to believe on a cellular level that the drug isn't just important, it's more important than food, family, anything. And the key player in this rewiring is a little molecule called delta phosphate. I want you to think of this as the master switch for addiction. Every time a drug is used, a little more of this stuff builds up in the brain's reward cells. But here's the crazy part. It's super stable. It doesn't go away quickly. It hangs around for weeks, even months, actively changing your brain's structure. So what does this master switch actually do? As it builds up, it starts flipping other switches in your cells. The end result is that it rewires the brain to be hypersensitive to the drug and cues for the drug. It basically cranks up the wanting system to 11, and crucially, it dismantles the brain's natural stop signals. It physically hardwires the brain for compulsion. And this leads to this really tragic and bizarre situation. It's called reward sensitization. As the brain changes, the wanting for the drug, that deep, gnawing craving, gets stronger and stronger. But at the exact same time, the actual pleasure, the liking of the drug, often gets weaker because of tolerance. So you're left with this intense, irrational craving for something that doesn't even make you feel that good anymore. That's the core of compulsion. Man, that sounds pretty grim, right? A master switch that physically changes your brain? It sounds permanent. But, and this is a huge but, it's not. This brings us right back to our original question. If all of that is true, how is recovery even possible?
And here it is. This is probably the most important message of all. This whole process, this rewiring, it's reversible. The brain is not broken forever.
Remember neuroplasticity, the brain's amazing ability to change itself? Well, it's both the villain and the hero of this story. The exact same process that lets addiction dig its claws in is the very same process that makes recovery possible. The brain can learn, and it can also unlearn. And this unlearning, this rewiring for recovery, it happens in all kinds of ways. Some people manage it on their own. So many others find help in community and peer support groups. And of course, many get there with the help of clinical professionals. There's no single right way to do it.
Over time, as long as the drug isn't in the picture, that relentless signaling stops. That delta phosB molecule slowly starts to fade away. The brain begins to heal itself, restoring its old healthy connections. Your prefrontal cortex, the CEO, starts to get back in charge, and natural things like food and friendship start to feel rewarding again.
Which brings us right back to this amazing number. Why does the relapse risk drop so dramatically after 5 years? Because after that much time, the brain has done a ton of healing. It has rewired itself back toward a much healthier state. It's not the same brain that was stuck in that compulsion loop anymore.
So there you have it. That's the answer. Recovery isn't just some miracle. It's possible because the most fundamental thing about our brain is that it's built to change. And if you give it new, healthy experiences, it can, and it absolutely will heal.
And that leaves us with one last thing to think about. If we know that addiction is a learned and reversible state of the brain, not a moral failing, how should that change how we see it? How should it change the way we talk about it and the way we support the people who are fighting every day to rewire their own path to recovery?